This is the second section of chapter 4, Flows in Networks 2, and this section is on sources and sinks. So this diagram represents what we might have, and what we can do is we can connect multiple sources to what we call a super source and multiple sinks to a super sink. So I've got multiple sources here. I've labelled them A and B. You may see these labelled as S1, S2, source 1 and source 2. And to enable us to solve these types of problems, what we will do is we'll connect these two sources to what we call a super source. And I'll call this S. And let me just change these letters back to A and B. And what I need to do is to work out the upper and lower capacity along these arcs here. And the way I do that is to add together the upper and lower capacity of the arcs coming out of this source. So this arc has a lower capacity of 5, this one has a lower capacity of 2, so combined that's a lower capacity of 7, and then 8 plus 9, that's an upper capacity of 17. If I do the same on the other arc down here, so I simply just add these numbers together, so 3 plus 17 gives me the lower capacity 20, and then 9 plus 20 gives me an upper capacity of 29. So that's for the sources. We can do the same for the sinks here. They can be labelled X and Y, or they may be labelled as T1, T2. And we joined these sinks together to form a super sink. I don't know if I said source before, but I meant sink. So this would be our super sink here, T. I'll change these back to what they were before, X and Y. And just like we work out the capacity by adding the flows together, we do the same here. So we're going to add together the lower flows, 3 plus 2, 5, and the upper capacity, so that's 19. And then for this arc here, from Y to T, that would be 3 plus 11, 14. And an upper capacity of 14 plus 8, which is going to be 22. If we have a network where there is just a capacity, there's no lower capacity, then we just simply add those numbers together. And last thing I just need to mention is that these arcs, which I've added to the super sink and the super source, they are not real. So they're not real pipes that exist, or connections that exist in a network. They are only there for the purposes of finding a maximal flow. So these help us to use our algorithm to work out a maximal flow. So we do not include them in a cut. So do not include these arcs I'm about to highlight in yellow. These ones here going to the super source and the super sink. Don't include those in a cut, because they are not part of the network. So when we're trying to work out a minimum cut to prove if you've got a maximal flow, these cuts or these arcs here shouldn't be included in that cut. Example 5. The diagram shows, that's this diagram here, shows a capacitated directed network. The capacity of each arc is shown on each arc. The numbers in the circles represent an initial flow. So the first thing we need to do in part A is to list the source vertices. Now source vertices only have vertexes or arcs leaving them, there are none arriving at them. So my source vertices are A, B and C. Part B lists the sink vertices. Now sink vertices only have vertices going into them, none coming out, and I can see that that's going to be H, F and I. Let's do it in alphabetical order, F, H and I. Part C, add supersource S and supersink T and appropriate arcs and flows on each diagram. Okay, so let me move my answers for part A and B up here, because I want the space to draw in my SUPERSINK over here. Okay, so I want to connect all of these points here, vertices, to a SUPERSOURCE here, and we're calling that S. And then I need to add the flows along them. Now here there's only a flow, there's no minimum capacity, sorry, there's just a capacity, no minimum capacity. So if this has 5 and 7, this line I've added here will have a source of 12. Then for A, 11 plus 5, this has a capacity of 16. Don't know why I keep saying source, I meant capacity. And for C, this has 5 here and 12 here, so this has a capacity of 17. I now add the capacity, and I just add these capacities here, or flow, 5 and 4, so that's going to be a flow of 9. From this one here, so got a flow of 8 and 3, so that gives a flow of 11 here. And then from here I have flows of 3 and 7, so that'll be a flow of 10 here. So remember, these are like virtual connections, virtual pipes. They don't exist, they're only for our algorithm. And then I will do my SUPERSINK over here, and we've been asked to call this T, and we'll do the same thing on each one. We'll write down the flow and the capacity. So here we've only just got the 4, so a capacity of 4, a flow of 4. For F, it has these two going into F, so this is going to have a capacity of 8 and a flow of 6. And then for the last one here, this is going to have a capacity of 18, 9 plus 9, and a flow of 17. Example 6. Water from 3 reservoirs, S1, S2 and S3, is used to supply 2 towns, T1 and T2, using a network of pipes. The capacity of each pipe is given by the number on each arc. The numbers in the circles represent an initial flow. So the capacity initial flow is given here. I've got a blank diagram here which I'm going to be using. Part A, add a SUPERSOURCE and SUPERSINK and appropriate arcs to the diagrams. So I'll start with my SUPERSOURCE here, and that's going to be S, and then my SUPERSINK at the other end, I'll label that as T. I now need to put the capacity and flow, or initial flow, along those arcs. So for the arc that goes from S to S1, I need to look at these pairs of values here, which I've highlighted at the top. So it's going to be 11 plus 11, a capacity of 22, and a initial flow of 19. For the arc which goes from S to S2, I now look at these values here. So I have a capacity of 17 and an initial flow of 15. And then looking at these pair of values to tell me what goes on the arc from S to S3, and that's going to be a capacity of 18 and an initial flow of 13. We're going to do the same for the sinks, so we want to add these together to find out what goes on the arc from T1 to T, and that's going to be a capacity of 32 and an initial flow of 26. And then lastly we look at these values here, we add them together, so T2 to t gives me a capacity of 30 and an initial flow of 21. Part B, use the initial flow and the labelling procedure to find the maximum flow through the network. List each flow augmenting route you use together with its flow. So we start by adding our forward and reverse arrows on all of our arcs, and then we'll add numbers onto here to show how much we can increase each of these arcs by and how much we can decrease each of these arcs by. So I'll do a couple of them and then I'll fill in the rest. So for example here, this one here, I can increase it by 3 because it's at current flow of 19, and it can be reduced down to 0 because there's no minimum capacity on this, so it can be reduced down by 19. And this one here, it can be increased by 2 or reduced down to 15. Right, so I'll fill in all the rest. So here's my completed diagram. I want to find a flow augmenting route. Now I want to avoid routes where I'm not going to increase flow, so can't increase by anything. Saturated arcs, so S1C is saturated, S2 to A is saturated, can't increase it by anything, and S3E is also saturated. I don't think there are any other saturated routes, so I'm not going to use these ones. I want to avoid those ones. There's a route here that looks promising because I can increase by 5, 5, and if I go this way, 4, 5, 9. So along this route here, S3, B, D, T2, T, looks like I can increase that route by 4. So let's highlight that route. I've written the route down here. You should always write down what your flow augmenting route is. So that's this route along here. So if we're going to augment this route, that means increasing the capacity by 4, which means that the amount I can increase the capacity by decreases by 4, and the amount that I can reduce it by increases by 4. So I'll do one of these and fill in the rest. Now normally what you do is you'd cross these out and write down your new values. So this would become 1 and this would become 17, for example, but I haven't got a lot of space here, so I'm actually going to rewrite the numbers. But in the exam you would actually cross out the numbers. You'd have a big picture of this, copy of this to work on. So we had 5 and 13, so 5 is going to go down by 4 to 1, and the 13 that was here is going to go up by 4 to 17. The 5 and 7 here are going to become 1 and 11. 4 and 8 is going to become 0 and 12. 5 and 7 here is going to become 1 and 11. And the 9 and 21 are going to become 5 and 25. So the flow along here has been increased by 4. So this 13 here now becomes 17. And the 21 here now becomes 25. So we should state its flow. That's what the question says, that once we've augmented a route, state its flow. So the flow is now going to be 25 plus 26. So this one gives us a flow of 51. Okay, so now the arc BD cannot be increased anymore, so that's now saturated. So we want to avoid using this route to see if we can augment any more. So looking at the routes, it looks like the most I can increase a route by is 2. So I've got 3, 3, 2, 4, 6. I can increase that route by 2. Even if I was to go this way, it's still 2. If I take this route here, 2, 2, 3, 4, 5, so it's still 2. and this root at the bottom, well, the most I'm going to be able to increase that by is 1. So I'm going to go through this root at the top here. So S1, A to C to T1 to T, and increase that by 2. So I've written the new root down and how much I can increase it by. Again, I've just rubbed out the previous one for space, but always keep all of your working in the exam and when you're doing any questions as practice questions. So since I'm going to augment or increase this root by 2, that means that the forward arrow is going to drop by 2 and the reverse arrow is going to increase by 2. So 319 is going to become 121. Let's do that in purple as we've done the others in purple. So 121. Here 3 and 8 is going to become 110. Then 29 is going to become 011. 420 is going to become 222. And 626 is going to become 428. That means that the flow along T1T goes up by 2, so that now becomes 28. So now I have a flow of 28 plus 25, 53. Okay, so let's get rid of that root and also any roots where they're now saturated. So AC is saturated now. And I should also change the flow along this source here. So that's gone up to 21. Put that in 21. Right, for the next route, well, along this route here, I can only increase it by 1 wherever I go after that. Here, 2, 2, 3, 4, 5. Yeah, so I can increase this route here by 2. And along the bottom is 1. So I'm going to go for this route here, which is S, S2, B, E, T2, T. So I'll now change the values along that route. So 215 is going to become 017. 017. 29 is going to become 011. 38 is going to become 110. 414 becomes 216. And 525 becomes 327. So that means that the flow here along this vertex is now 27, so we'll change that to 27. Or sorry, flow along that arc is 27, and the flow along here is now 17, so we'll change that to 17. Okay, and now we'll look at any arcs which are saturated. So this is now saturated, this is saturated, and I think that's it. So now I've got a flow of 55. Now whichever routes I use, I can only increase them by 1. So we'll go for this route here. And we'll increase the flow by 1. So I've completed the changing of the values along that route, and I've changed like the actual flow along those routes. This now changes to 18, this changes to 28. I've now got a flow of 56. So again, what I'm looking for are any saturated routes. So this is saturated, can't use that. This is saturated, this is saturated. Okay, and the only route left I can take, which is going to give me an increase of 1, is going to be this route at the top here. So I'll highlight this, and I'll do the same thing again, change the values and change the flows. So completing that, I now have a flow of 28 plus 29, which is 57. Let's see if I can continue any further. So what happens to roots which are saturated? Ah, well, that's saturated, so I can't go any further. So hopefully I found a maximal flow here. Part C, what I need to do is draw my maximal flow pattern. So basically write down what the new flows are on each arc. So let's get rid of all the stuff that we don't need. So basically a flow is going to be how much you can decrease it by. So these ones here at the start, they're all saturated, so it's just those values here. I can decrease them down to 0, so we'll get rid of all of those bits here. Actually, let's put that arc back in. Actually accidentally deleted. So we're just looking at the values which are at the bottom. So this one here is going to be 11, so we'll get rid of that. That was a saturated arc. Saturated one's easy to do. This one's going to be 11 here. I'll do one more and then the rest I'll just fill in. This one here is going to be 6. So here are the remaining flows. Okay, and then part D, state the value of your flow. We only need to state it, we've written that already, so that's 57. And part E, what we need to do is to show that there are 2 minimum cuts. Now remember, minimum cuts, when we've got a SUPERSINK or a SUPERSOURCE, these extra vertices that we've added don't form part of that, so don't draw your minimum cut across the vertices here to the SUPERSINK or the vertices here from the SUPERSOURCE. So I've highlighted my saturated arcs because I want my cut to pass through there, so I could have a cut that goes through these vertices here, so I'll call that C1. So not vertices, edges, arcs, and I can have another cut, let's see, through here, and I'll call that C2. And that also passes through the saturated arc. So yeah, there are 2 possible cuts with this network. And if we work out the value of these cuts, they are both 57, which matches the flow, so we know that flow is a maximal flow. Example 7. The diagram shows a network of oil pipes with separate sources S1 and S2. So S1 and S2 here, and separate sinks T1 and T2. The numbers on the arcs represent the lower and upper capacities through the pipes. First of all, we need to add a SUPERSOURCE and SUPERSINK to the network with appropriate arcs. Label the new arcs with their lower and upper capacities. Okay, so let's do that. Here, we'll label this S, and we'll do the same to the sink here, and we'll label this T. And if we want to write the capacities down, then the minimum capacity is going to be the sum of the minimum capacities at S1, which is going to be 30, and its upper capacity is going to be 25 plus 16, which is going to be 41. And if we do the same down here, 10 plus 10, 20, and 20 plus 12, 32. We'll do the same at the sink end. So we're going to have 15 and 30 up here, and for this arc down here we're going to have 26 and 43. Part B, it says the diagram shows a partly completed feasible flow for the network, so that's this one down here. Complete the diagram to show a feasible flow of 64. So that means I need to have 64 flowing out of this super source and 64 flowing into this super sink. Okay, so we can just use the numbers we've got here. So if I've got 16 and 12 flowing out of S2, using the conservation condition, I must also have the same amount flowing in. So this has to be 28 flowing in here. It's a feasible flow of 64. So that means that both S to S2 and S to S1 need to add up to 64. So I'm going to take 28 away from 64, and that gives a flow of 36 here. So I've got 21 flowing here. If I've got 36 flowing in, just do 36 minus 21, and that gives me 15 on S1 to A. And we just move along. It's a bit like a puzzle really. So what have I got here? 15 flowing in. I've got 7 there. So this one has to be 8. Like this. Any other missing ones? So I've got all of these here. Right. Let's get across to this one. Right. I've got 7 and 22 going in to C. So 29 going in. I need to have 29 coming out. So this needs to be 8. Moving on to T1 to T, 8 and 19 going in, so that must be 27 flowing out. Then I have 21 flowing into F, I need to have 21 flowing out, so F to T2 needs to be 2. And I think that's now completed. I can't see any arcs that don't have any numbers on. I think that's completed now, so we can go on to part C. Prove that 64 is the maximum flow for the network. So the first thing I'm going to do is to highlight the saturated arc, so I can see that AC is saturated. So we'll highlight that because I want my arc to pass through those. Right, this arc here, DC, is saturated. It's at its full flow, so we'll mark that in as well. I can also see that DE is saturated. It's up to 23, and the edge along the bottom, arc along the bottom, S2 to E, is also saturated as well. E to T2 is saturated because I've got 35. So I think that's all my saturated arcs. So I want my cut to pass through there. Now I've got a couple of options. So my cut could pass through here, so I'll call that C1, or my cut could pass through here instead. We'll call this C2, but what we're interested in is to work out the value of the cut. So this is a minimum cut, so value of C1 is going to be 7 plus, now I can't see that number anymore, it was there, what was that? Oh, that was 22 there, let's put that back in. So 7 plus 22 plus 23 plus 12, and that's 64. Or I could have used cut C2, which is 7 plus 22 plus 35, and that is also 64. So we finish this off by saying, so by the minimum cut, maximum flow theorem, C4 is a maximal, or sorry, 64 is a maximal flow. So you should now be able to do exercise 4B on pages 125 to 127 of the textbook.